In this pre-calculus algebra video, we're going to solve a system of inequalities. To start this, let's make sure we understand what an inequality would look like when we graph it. Let's look at what we get if we graphed a line. Let's say just the basic y equals negative 3x plus 4. We'd have the y-intercept of 4, b equals 4. So we could start our line as the y-intercept of 4, and then the slope is negative 3, or negative 3 over 1. So we'd go down 3, right 1 to get each consecutive point, or up 3, left 1. So that's equivalent to positive 3, negative 1. But we'd get this line that you see drawn. Notice that this line, if we look at the coordinate plane, and we think of this as a plane that extends in every direction, then we've got the scenario where this line that cuts through the plane is dividing the entire plane into two halves. We've got this left half that contains the 0, 0, and we've got the right half of the plane to the right. So we could see that a line cuts a plane into two halves. If I want to now solve a system, or not a system, I'm sorry, if I now want to solve inequality, let's say that we'll take this related line and say y is less than 3x plus 4, then that inequality is now going to be a half plane. The graph of the inequality will be either the right half of the plane, the part that's to the right of our line, or it'll be the left half of the plane. I can determine which side it's going to be on by picking a test point. So why don't I test 0, 0? If I put a 0 in for x and a 0 in for y, I get that 0 is less than 4, which is true. So it looks like the half plane that includes this point 0, 0 is this part of the plane, the half of the plane that's to the left of the line over here, because it contains our test point 0, 0. And so a graph of an inequality with two variables would be a half plane. Let's look at another example. If I want to graph x minus 2y is greater than 10, the first thing I'll do is I'll solve for y. And to solve for y, I'm going to subtract x from both sides. So I'd have x minus 2y minus x leaves us negative 2y is greater than 10 minus x, or negative x plus 10. And then when I divide by, if I'm solving for y, I'm going to divide by negative 2. But when I divide by negative 2, notice that the inequality changes from greater than to less than. So I negative 2y divided by negative 2 is less than the opposite of x divided by negative 2 plus 10 divided by 2 by negative 2. So that leaves us y is less than positive 1/2 x minus 5. Now with this negative x over negative 2, I've just divided out, pulled out that 1/2. So the negative divided by negative turned to positive, and then I factored out a 1/2 to get y is less than 1/2 x minus 5. If I think of this in y equals mx plus b form, then the m is going to be 1/2, and the b is going to be negative 5. So I can graph that line, the related line, y equals 1/2 x minus 5, by starting at negative 5, b equals negative 5, and then I'm going to move up 1 and right 2, up 1, right 2, to get each new point, or down 1, left 2, to get each new point. So I could get this set of points. And because this inequality is written as a less than, it's not or equal to, because it's less than and not or equal to, when I draw the line itself, I'm going to have a broken line like this, not a solid line. Now, if this inequality said or equal to, then I'd have a solid line. But our example says less than, so we've got this broken line. The next step in solving the inequality, graphing the inequality, is to decide which half of the plane. Do I want to shade this half of the plane, or do I want to shade the lower half of the plane? Well, there's two ways to do it. I'm going to start with the official way, but then I'll show you a shortcut. If you're paying really good attention and follow to the end of the video, I'll show you a shortcut here. But the official way is I'm going to do a test point. I'm going to test this 0, 0. I'm going to replace x with 0 and replace y with 0 and see if I get a true statement. So when x is 0 and y is 0, I'd have 0 minus 0, which is 0, is greater than 10. And that's not true, is it? Because 0 is not greater than 10. So I know that I don't want the half plane that includes 0, 0. I want instead to exclude the 0, 0. So what I'm going to do is shade in the lower half of the plane. That's this part down here. And this half plane with its broken line would be the solution to x minus 2y is greater than 10. Now, I promised you a shortcut. Here it is. It's really easy if you get the hang of this. If you write your inequality in a way that starts y on the left, the y has to be on the left, and then we have our inequality symbol, such as y is less than, then we could see our line, y equals 1/2 x minus 5, is right here dividing the half plane. But if I want all the y's that are less than that line, then I'm going to have this part of the plane that's down below the line. If I change that inequality to y is greater than, then I would have selected the part of the plane that is above the line, and that's a shortcut. Now, beware, it only works if we're solved for y, and that y has to be isolated, right? So then we look for less than, we look at what's below the line. Let's try another example now. Let's graph a vertical line, x equals 1, and then we'll use that vertical line, x equals 1, to graph the related half plane. So if x equals 1, it's this vertical line right here, and our inequality is x is less than or equal to 1, so we'll include our x equals 1, and we also want anything that's less than that. So the part that's going to be less is the part below. Oh, I can't believe I was following the example to the right. I don't know if you caught that, but we want the vertical line. In this next example, we're going to graph x is less than or equal to 1. We'll start with our related line, x equals 1. And since our half plane includes the 1, because it says or equal to, we'll have a solid line for x equals 1. And if we want all the x's that are less than 1, we're going to shade everything that's to the right of 1, because these are all the x's that are lower than 1. Now, that's the unofficial shortcut. We could also do a test point. So if I were to test the point 0, 0, and as long as 0, 0 isn't on the line, it is in fact the best test point there is. We're testing, is 0 less than or equal to 1? Yes, it is. So we know that the 0 is included in the solution that we select. 0 is included, 0, 0 is included in the solution set in the half plane. Let's try another example. This example, we're graphing a circle. In this circle, x squared plus y squared equals 25. That would be the related line, or the related circle. It's going to have center 0, 0, and radius of 5, so you can see that I've outlined that circle here to the right. Our inequality is a greater than, so it is not including the line, but just what's outside the line. If I were to do a test point, you might already be able to use the shortcut, but if I do a test point, let's check, do we want what's inside the circle? So we could pick this 0, 0, or do we want what's outside the circle? 0 plus 0 is 0, and 0 is not greater than 25. So you guessed it, we don't want to shade what's inside the circle. We're going to shade everything outside the circle. It's more than the half plane. It's the entire plane except for what's inside the circle. But if you guessed it, the shortcut we can use is, if we wanted everything that's greater than that circle, it would be going out from the circle, right? So that's another way we would know to shade outward, not to shade the actual circle. Let's look at an example. The normal respiratory rate region for children ages 3 to 15 can be modeled by the following system of linear equations. This is a great example for our healthcare professionals. And we have this system, and we want to show that 522 is one of the solutions of the system of inequalities that describe normal respiratory rate for this age group. So what I'm going to do is replace the x with 5, replace the y with 22, and I'm going to do that for each of the equations and see if it comes out for a true statement. And when I use my calculator, 8200ths times 5 plus 22, I'd get 26 1/10, which is greater than 24. So it looks like the ordered pair 522 does satisfy the first inequality. Let's check the second inequality, 7600ths times 5 plus 22. If I put that on a calculator, I would get that 25 8/10, which is in fact less than or equal to 27. So it looks like our ordered pair satisfies the second equation as well. They're both true. So I can say that this is a solution. This is a solution of the system. 522 is a solution. Let's try one last example. In this example, we're going to graph the solution of the system. Y is greater than 2x minus 3, and y is less than negative x plus 6. If I start with y equals 2x minus 3, do you see that I have that in pink here? The b is negative 3, so the slope the y-intercept is negative 3. The slope is 2, or 2 over 1, so I'd go up 2, right 1, and I'd get this pink line. It's a broken line. I'm drawing this as a broken line because the inequality says greater than, not greater than or equal to. Can you see, by the way, where I'm going to shade? I'm going to shade what's above the line, so to the left. So I know by using that shortcut that this test point 0, 0 should work. But let's go ahead and test it. Is 0 greater than negative 3? Yes, it is. So I know that this 0, 0 point is in the solution set for the pink line anyhow. I'm going to go ahead and shade that. The pink part that's shaded is this half plane. So the solving the half plane that solves the first equation is what you see shaded in pink. And now for the second equation, y equals negative x plus 6 is a related line. B is 6, and the slope of negative 1 would mean I'd go down 1, right 1, and keep going, and I'd get this broken line that you can see displayed here. I know by using that shortcut that the half plane I'm going to select is the half plane that's below that line, but I'll go ahead and do a test point, and I'm checking whether this 0, 0 solves this or not. And we see that the 0, 0, 0 is, oh, for the test point it should be equal to, or less than, right? So we're checking, is this less than? Is 0 less than 6? Yes, it is. So it looks like this 0, 0 is also part of the blue solution. So let me shade that in. That'd be this part. And the solution to the system is going to be the purple piece. Do you see what I mean by purple? The purple part is this part that's both pink and blue at the same time. So make it really clear. Let me go over it with this darker color. So the solution set is this quarter of the plane, a quarter plane, with the boundaries y equals x minus 3, or 2x minus 3, and y equals the opposite of x plus 6, but this piece that's to the left, the purple piece, would be the final solution. To solve a system of inequalities, what we want to do is graph each half plane and then determine which part is shaded for both. Notice, by the way, that this corner point itself, let me make sure I'm clear with this. Notice that this corner point itself is not included, right? Do you see that? That this corner point where the two lines intersected, looks like that's 3, 3. That corner point isn't part of the solution. If I let x equal 3 and y equal 3, we wouldn't get a true statement. But everything right up to that point is in fact included. I hope that this video has helped you better understand systems of linear inequalities or nonlinear inequalities as well, like that circle. Please jot some notes down if you have any questions. I'd be happy to go over those in class.